Okay, this is the first step to the tool bit grinder, meaning for metal lathe, fly cutters, and etc. It's going to grind both high-speed steel and carbide. Now what I'm doing, this is a plate, a 3/8 inch steel plate that I had on another project I built to grind carbide saw blades, and pretty much done doing woodworking, so I figured I'd make use of this piece. And first thing we're going to do is spot some holes here with a spotting drill, and nothing has to be too accurate, mainly if I get my hand to quit shaking long enough to do it. I have an old drill press sitting over there. It's near about as old as I am, but it's got so much crap piled on it I opted just to use a milling machine. By the way, this is a little Clausing 8520 knee mill. Next thing, we'll change this bit out and drill the through holes. Okay, we set up, I went ahead and put a work piece of board in here. It's got a 2-inch piece screwed to the bottom of it. Gives me a little work platform to hold this steel plate. And of course it's sacrificial, so you just make all you want of them and keep on going. Dropper fuel oil. I like to make short pulls on it. Keeps the pieces of metal coming out of there a little shorter, easier to vacuum up. I don't carry quite as many of them in the house and get them in the wife's carpet. And we just do the same thing all the way around. You may or may not be able to see there's a bunch of holes in this plate, like I said already. I'm just repurposing it. I used to live close to a place that had a lot of drop and scrap and stuff. You'd win by it for the pound, but anymore, getting close to 80, I'm not buying much material, but I still like to get out here and mess around a little in the shop. Alright, I won't bother you with any more of this. Okay, we're back, and just to recap, we drilled our spot drill pilot, went through with a 5/16 stub bit, and this is a solid countersink, carbide countersink. The thing about this is that this is a 1-inch unit, and this milling machine is actually made for up to 1/2 inch. So I also put a variable speed drive on the old Clausing, did away with all the belts and the belt gear reduction, the center one. And so to run this bit should only run about 400 RPM, but at that speed on the variable speed DC motor I lose quite a bit of torque. Shouldn't, but I do. So anyway, we just have to take it slow and easy. Does pretty well until you get in away. Not really too bad, but you know, if you're looking for something real fast, this is a little underpowered. We'll go ahead and drill the other ones offline and be back. All right, we're back. First thing, let me apologize for the video on the first part of this, which was with this piece of 3/8 plate in my glazing milling machine, drilling the holes to mount the rubber feet on. I thought it was a smart thing to do is put LED, I'll call them little spotlights, floodlights in my lighting on my milling machine. Now it helps me see better, but it does terrible things to the video. It just washes it out, and it's just ugly. So anyway, here's the legs mounted, the rubber feet, and I have them just temporary mounted. They will be anchored with shallow lock nuts, nylock type nuts when I'm done. So proposed excuse me, this is a piece of 1-inch aluminum plate. I started out with a piece of this about 36-inch square some years back, and that will mount back here, and there'll be a hole machined in here and a split put in the top to where the grinder motor will stick through, and a bolt will squeeze it and hold the grinder in place. So right now what I'm trying to do is build an adjustable table, and this is something that I had built some time back for another project, and it allowed me to turn it to get angles. I decided against that, and so I went on eBay and I bought a cheap adjustable angle table. It's about I guess maybe 5.5 by 7 or something like that, that'll set in here. And of course, you know, it was a cheap one. Came what I thought from China, but really it came from India, which makes it that much worse. So we'll step over here in a second and show you where we're at on that. So here's a picture of the little adjustable angle table, and the first thing I did was loosen up the lock nuts under here, and it's got a crank that goes out here, and I tried to turn it, and you could barely turn it. Gritty, grindy, nasty. So what I'm doing right now, I took some valve lapping compound, I took it all apart, and I put lapping compound up in here, and I've set it here, and I've been doing this for quite some time, and I've actually got it now to where another 15 minutes of this and I think we'll have something that's actually usable. So it is side specific, so I am lapping in just one side, so one way. Alright, you don't want to watch me do that for an hour. So the second thing that was absolutely worthless is this thing has a set of worm gears that I will say barely work. And at first you couldn't even turn it, barely turn it with the crank on, and that's because the ball bearings, I think they lubricated them with metal chips. But even after taking the seal out and cleaning them again and greasing them properly, what I noticed is when the shaft goes in, nothing fits. Now, I don't know if the bearing is oversized or if the shaft is undersized or if it makes any difference. But I did, these are just plain old 6001 RS bearings. They're 12 millimeter by 28 by about 8 millimeter thick. And I ordered some off of eBay from a vendor I've ordered from before, and his bearings are Chinese bearings, but they're 100% better than these. So I'm waiting on those to come in. And this goes up under the table and has a crank that goes on it that whenever you get this thing to somewhat where it should be, you can adjust in your angle. And there'll be another table on top here that my actually milling machine cutters and lathe bits and stuff are locked down to. Okay, that's what we're doing today. Okay, so here we're back, and it seemed like just a split second, but actuality it's about 2 hours. And by using actually valve lapping compound between the two mating surfaces of this table, you can see the dark lines in here. That's where we lap these things in, and there's the other piece over here, and the same thing with it. So now this relatively fits this. Okay, the next problem was that these little pieces draw up from underneath here like so, and this bolt goes through the other part and allows you to adjust the tightness of this. So when you get it to the angle you want, you just lock it down. Well, they were poorly cast, I'll just use that word. They looked like, I know you can't see the roughness, but this is terribly rough. So I managed to work those down to where they fit fairly well up in there. And then up inside of here, and that may be hard to see, but this shiny part right here was also terribly rough. And I just used a good flat file and cleaned that up on both sides and both ends. So now we're actually to the point to where we could put this thing back together, but not having good bearings for this crank unit, I'm just going to put it back together temporarily, and this thing sits this way and the worm gear fits down in here. Now when I get good bearings and can tighten up, I don't know if you can see this, how much that's moving, but it's, I don't know. Anyway, my hope is to be able to adjust this up and down either with shims or by milling off a little bit here to make it, the worm, fit into the other part, because it really doesn't work well at all. And I don't want to try to hand file all that to make it fit. So when you buy a $70 unit like this, you get a $70 unit. It's certainly not German quality, and you wouldn't expect it. But with a little bit of time, you can make it better. On to the next step. Okay, here's the next thing we're going to address on this. Now, understand this is not a surface plate, but I have one over there that I used. You might be able to hear this better than see it. But I'm going to have to mount that in the milling machine and try to zero it in the best I can, and then mill it flat on the bottom side. I'll leave the tabletop alone, so that'll be set up next. Okay, you know how you think things are going to be easy. I thought I could just have this thing upside down, sitting on my milling machine table, lock it down, throw a fly cutter in, zip off the bottom of these things to where they're level. I was going to use, of course, a gauge to level it on the bottom to make sure it was setting at 0. Well, there's bevels on the bottom of everything here. There's no way to get into it from the end of the table to hold it. So right now what I've done is I'm in the process of leveling this front to back, because right to left I can't do anything with. And when I get that leveled, not that it has to be perfectly level, but I'm going to drill a hole down through here, and it'll allow me to bolt it from this top piece from the underside up this way and down into a T-nut into the tabletop. So anyway, here's where I'm at for the, we're setting at 0, dropping off about 10 thousandths through the hole, back to 0. Now don't forget the base is not perfectly flat, so I'm happy to get it. So far it's about not even a half a thousandths off from front to back. And there we are, clear at the back. That's as far as my table throw will go. All right, we'll try to get this drilled and set up and take another look at it. Thank you. All right, we're set up in the mill now with the through hole bored through. We're bolted down here and here, and plus a couple toe clamps out here. We really don't need to use lubricant on this, but this is my second time across. First time it was terribly uneven. This time we'll see what happens. I understand this little closing. The maximum bit capacity is supposed to be a ½ inch, and we're cutting about 2 1/8. So it's a little bit more than it should be handling, but still, there's no vibration in the table. This goes so slow, I'm only going to bore you with this one side, and I'll simply traverse over here and go the other direction. Then I'll put a dial indicator back in the machine and see just how close we are. The only thing I can think is we might be end up a little high in the middle here when I release those 2 hold down bolts holding it to the table. I might have pulled the casting down a couple thousandths, I don't know. But if I did, I'll take those bolts out, and I think no more than I'll take a skim cut and leave these hold downs in place. As you well know, there's a lot of chatter on the internet about fly cutters, the bits, how you grind them. This is strictly a piece of high-speed steel with a full round nose on it with about a 7-degree relief angle on the lead edge and on the top edge. I don't know if you'll be able to see it or not. But anyway, that's what it looks like. All right, here we are. We're back at this, and we've got the base plate for this grinding unit mounted up in the closing again. And we've got some of our homemade riser blocks set up here. And this was just made out of a bunch of scrap aluminum I had, 1/2 and 1/4 inch. And it allows you to swing them over and adjust the height of your riser blocks. Anyway, we got them on both sides. I can see them over here. Right now we've got a wiggler set up in here, and what we're going to do is, of course you've seen this 100 times, so it's like nothing new. But anyway, get your bifocals lined up to where you can see what you're doing. Get it set up, and then just run your mill table over, drop it down. And this isn't precision stuff by any means, so when you get it to where you want it, drop the wiggler out. Take our spotting drill, come down and spot our hole. And spotting bit out. And as you can see, as you get old, you get a little bit fumble fingered, but it sure beats setting in the house. And now we simply drill our tap hole for 3/8, 16 is 5/16. Like so. Now my mill does not have the power to power tap into this 3/8 steel plate, but what I do is mount it lock it down, a little bit of oil, fire it up, and let it go as far as it can. That's it. And back it out. And I do the rest by hand. All right, an update here. We got the 2 holes drilled and tapped out here to actually mount the angle unit. Back in the back here is going to be end up a vertical support to support the actual grinder motor. And to get the height I need, I'm going to put this 1.5 by 1.5 piece here in this recess. And like I told you, this was used from another project. All right, so I've come through so far and drilled with the 3/8 tap size drill, 5/16 all the way through here. All right, and the end 2 holes, I'm going to tap this aluminum block just to hold it in place, and then the actual riser that holds the unit will set on top of that, like so. And let me get back far enough you can actually see that. So got the base, this riser I had to put in, and then this one piece of 1-inch block aluminum. And 2 or 3 of the holes will come up all the way from through the steel plate, through this riser, and be tapped into here, and those will be 3/8/16. So anyway, we're drilling the last few holes. So the main thing for me to remember is not to drill these to 3/8 because I want to use those as pilot holes when I flip this whole rig over. Then I can actually drill up from the bottom and get everything centered back. So right now I've got my 3/8 bit in here, and we're just going to open up these 5/16 holes here. And remember what I said, don't let me forget. I don't want those 3/8 for right now. But anyway, I didn't go all the way through like I would normally do, so we're still good to go here. These will get, the center 3 get drilled all the way through. Now this center one here might be a little exciting because it's going to go into an existing hole. I probably should stop and put an end mill in. But we're going to tighten up the quill a little bit. And try to make it and see what happens. Well, as soon as I get it where it belongs. So here we go. Probably drilled a bit oversized, but for what I'm doing it doesn't make any difference. So, and the last one here. And that's about it. I'll quit boring you with drilling holes. And sorry for my arm being in the way. Okay, I'd really thought about not showing this process because it's given me such a pain. I don't know what this aluminum is, and I'm talking the big 1.5-inch square block down below. I'm going to turn a light out here. Yeah, I think that's better. Anyway, it's so gummy. I've tried, you know, the old standby WD-40. I've mixed marble oil, magic marble oil with it. Use regular oil. And the only thing I found that works is to go down just, you know, a 1/16 of an inch and then clear the chips like so, blow them out. If I don't do that, it creates a ball of crap at the bottom, and then the bit spins on it. Now this bit drills other aluminum and steel perfectly well. So anyway, the next thing we'll do is we'll go ahead and tap these for to actually hold down the plate to the riser, and I'll do that off camera and we'll get back with you. Okay, here we are back to one of the last holes in the base of this thing, I hope. And of course, by reusing this, it did give me trouble going back through this hole that already had a hole beside it, which we kind of knew it would. Anyway, here's some of the last hole we're going to drill in this, I hope. Remember to clear your chips once in a while. Okay, once again I got a piece in the bottom of that hole spinning around and won't let me feed, so you don't need to watch that. But the next step would be tapping a couple of these holes. Okay, I'm going to try to get this shot of power tapping without getting enough stuff in the way that I can't get to the power switch in case something goes astray. But here we go. Does a pretty good job. It won't do that in steel though. Alright, this is just a quick shot of me trying to square up the back of this riser aluminum block with the back of the 3/8 inch steel plate. Nothing but just it's for looks is all. Making a whole lot of chips for nothing really, but now this is climb cutting, so I can't really take a big cut. But it's 120 turns of this crank to get from one end of this to the other. And I have bad shoulders anyway, so I'm not going to waste a trip back without doing some cutting. There's a tiny bit of vibration in the table, but remember this is a 1/2 inch maximum capacity. That's a 7/8 inch bit. It does fairly well in aluminum. And I certainly won't bore you with 5 minutes of going across this straight cut. Okay, let me try to explain what I'm doing with this big convoluted mess of clamps and crap. I got the base all done, and I've got the 1 inch thick back plate that's going to support the actual arbor shaft of the motor, and it's standing vertically in here. And you have to understand that I only got about 4 inches of throw on this whole mill table in and out. And so I've got a piece of 1.5 inch aluminum bar stock down here, and as you can see I've got it clamped down here. And what I like to use are adjustable parallels. I've got an old pair, and I just tighten them up pretty tight, and I set them in my T-slots and I tap them with a hammer, and it really tightens them up. So, and that gets you within a couple thousandths of square down the length of your table. Okay, so then attached to this piece of aluminum, we have, I'm not even sure you can see it. I'm going to make you dizzy here. Okay, we've got the actual piece that I'm trying to get matching holes in. I'm trying to match the holes to this base to the vertical plate that's going to go up in the back. So that aluminum vertical plate is clamped to the piece 1.5 inches down here I showed you. And then we come up here and I took another piece of 1x2 aluminum and C-clamped it across here on both sides and leveled it. And then last but not least, let me shut this off. Last but not least, I clamped this whole base plate assembly to the top using a couple more cant twist clamps. And by the way, those are the best things since sliced bread. Then I simply lined up this hole just using a 3/8 bit, and then I ran back and forth to these holes and made sure they lined up. So now what I'm actually ready to do is do what I really started to an hour and a half ago, is drill these holes straight down through all of this, through the 3/8 plate and down into this 1-inch thick aluminum vertical back plate. Okay, thanks. Okay, here we are with the plate. I had all that contraption set up on top, getting these holes set in here, and we're just going to power tap them now. And we'll just countersink them a tad so the bolt can kind of funnel in there a bit. And there we are. Later. Well, we're back. Not that it'll stay mounted, but we've got the tilt table mounted here. We put all of our other tables and the linear bearings and all on top to find or try to establish a center line. And we got this back plate drilled and mounted. Of course, it'll have to come off. It's got to have about 1.5 inch hole put through it here. And then up at the top, we'll split it with a slitting saw and drill and tap it to clamp the motor. So the motor will set coming through like this. That's where we're at now. What I'm trying to figure out now is I'd like to do this in a 4-jaw chuck on the Logan lathe, but I'm not sure I've got enough swing because it's so far off center and probably be a little dangerous. So I'm sure it'll be mounted in the closing and just use a boring head, drill it out with the largest bit I have, and then go to a boring head. So that's the update now. Well, I just had to try it. It wouldn't allow me, my Logan wouldn't allow me to swing it, and that's probably a good thing. So back over here, and with this closing, I just have to take quite a few cuts, and not gonna bore you a lot by drilling holes. This is that piece of a mystery aluminum that is really, really gummy. So, anyway, we get this thing out a ways, and then we'll put the boring head in because I've only got up to a 1-inch bit. So later. Alright, we've changed over to the boring head, and I'm taking a pretty healthy cut, probably 250, 300 thousandths, and for this machine that's a lot. I hope you enjoyed that high-pitched squeal as much as I did. But anyway, we'll try to get this thing pushed out to about 175 thousandths like it needs to be, and be back. Alright, I think we're within about 4 thousandths or so of my target diameter for this hole. Now we'll just run down through here. Then we'll measure it and see just how close we are. Well, the casting I'm trying to fit this to isn't round, so we're going to go another thousandths, which will give me 2. And when I split the top of this, I'll still be in good shape, I think. Anyway, hopefully this is the last time we'll go down through this thing. I have no way to make that motor extension cast housing perfectly round, so this is about the best I can do. Alright, see you later. Okay, we've finished the hole to mount the grinder motor, and what I always try to do is, next thing I'm going to do is cut a slit in here, and then we'll machine the sides out a bit over here and here so we can put a through bolt through to pull this in and pinch it on the motor. But what I'd like to do is bring this up, just use my electric drill, it's a lot easier, like so, and bring the quill down and mark where I want that line to go. And I mean, you can do this a lot of ways, but anyway, simply drag it through like so, and I've got a nice line to go ahead and put my slit in. So that's all there is to that. So we'll be back when we get this set up, and we'll use a slitting saw to go ahead and cut that in there and be on our way to the next little process. Okay, I'm not going to bother you with all of this because I can tell right now the way these slitting saws and the small arbors and the big quill, I'm not going to make it all the way through, but we'll cut it as far as we can. So what I'm going to do now is try to cut it from the back side and the front side to get through it. Okay, once again, I'm being forced to do something you shouldn't do, but I'm only taking about a 10,000ths cut to clean up the top of this thing. I'd have rather had it laying down flat and run it, but I don't want to pull this table, the vise off the table again. So I'm getting no vibration whatsoever. I do have a 1-inch cutter, but if I go across this 1-inch plate, I'm going to end up with a sharp edge on both sides. Using a 7/8, I go down cutting one way and come back cutting the other, and it leaves no sharp edges. I hate to make you suffer through this, but I want to get all the way across. There we go. Then I'll do the same thing on the way back. See you in a bit. Alright, let me catch you up. I didn't film all this because for me it's very, very time consuming, and I'm sure you wouldn't be too interested in it. But what I was trying to do, I finally got this turned out to the right diameter. I split this for a through bolt to go through and clamp it to secure the shaft of the grinding unit. And my next thing was to lay out the outer sides of this, because with all this in place I would not be able to squeeze, put any tension to hold the grinder in place. So I turned this little plug to go in here and simply took protractor and scribed the outside edges of this. Then I turned around, I had some holes over here, and I scribed the inside edges on both sides. And then I went to my poor old bandsaw, which of course is a wood cutting bandsaw, but you know, it's a fair one. And I have a blade in it that I use strictly for cutting aluminum, and it does a pretty good job, believe it or not, on this 1-inch. So I come in here first on both sides, then I sliced down through, got as close as I could to my finished product here. Got rid of these pieces. Then I come in and cut in through here and got rid of these pieces on both sides. And then lastly, I turned it around and came this direction and got rid of these small pieces up here. Alright, that takes care of the bandsaw work and making the plug and all that. Alright, so now I'm over on a belt sander trying to clean up the outside edges from the bandsaw. Just, you know, doesn't make any difference, just makes it look presentable. It's a little dark over here. But anyway, here's what I'm starting with. You can see it's pretty crummy looking, but that's from all the trying to make it around corners with a bandsaw blade that's too wide to go around a corner. And this is a side that I got just this edge cleaned up, and you probably can't see it well, but I got to get the inside radius, and I'm going to do that on my spindle sander. So this is what I'm going to do next, and I'll just do just a hair of it because this is a noisy rig. I got a vacuum hooked up to both of my sanders, and pretty noisy. Okay, so you see how it's done. It's a long process, and as you saw, my bulb went out. That's a LED bulb. It's got a problem with it, and I'm gonna make you a little dizzy here. Okay, this is a sander I built a couple years ago. Built this from scratch using the backbone of it is this same 1-inch plate. So this whole backbone here is all 1-inch solid piece. This was all made from just scrap aluminum, 5/8, 5/8, a lot of 1-inch, half. But this is a really nice unit, and it's got a DC variable speed motor on it. I love it. Too big for this job though. Alright, we're set up here now, and this is going to be drilled and tapped to 5/16 by 18. This is a letter F in here. And this is that hard drilling stuff, but we're just going to kind of squeal our way through it. I'm drilling the threading hole, the F all the way through, and then we'll come back through and only drill halfway through for the clearance hole. I put this plug in here. Not that there's enough flex to hurt anything, I don't think, but anyway, I had it, why not use it? Okay. There's the tap hole, and we'll get the clearance hole. Okay, we're back, and we're going to drill the clearance hole. And I've got a ruler here that I despise anyway, so I just use it to stop me going through, because some of these bits get pretty grabby, especially when they're new, and I can feel it. There, I'm against it. Then off camera, what I'll do is I'll set my stop so it can't go but just a hair further. Well, nothing very interesting here, but I went ahead and got this drilled and tapped, and the lockdown bolt put in it so I can snug up the actual drill motor, or the grinder motor. This, as you can see, it's been cleaned up and radiused out fairly well, and I'm not going to spend forever trying to make it look beautiful because it's just a functional tool. So anyway, we'll go ahead and get it mounted back to the base, get the motor hung in it, get a wheel on it, and then try to figure out our tables as far as width and throw and how much angle I want to put on them and all that good stuff. Alright, we've got the motor mounted on the grinder base and upright and everything. And we've got the little adjustable angle table mounted, and I have to make some, well, I won't call them T-nuts because they're not going to be a T-nut, they're just going to be a flat that fits up in the T-nut hole, and that will actually just hold down the first plate that I'm going to start building my movable grinding platform on. So with all that said, this is simply a matter of drilling a few holes. And I'm going to tap them 1/4 20, so this is just a number 7 bit. These are 1 inch apart. Going to make them all, tap them, and then cut them off with power bandsaw. If I'd have been thinking ahead, I'd have had the tap here. Okay, don't forget, this is kind of a, you know, a proof of concept type thing. Have no plans, have a kind of an idea in my head what I want to do. So just to recap now, the base is pretty well done. The tilting angle unit has pretty much been cleaned up. The ball bearings to fix it so it actually works, supposed to be in today. The back motor mount's all done. This collar's cut, fairly well cleaned up. Motor's mounted solid. Guess it'd run better if it was plugged in. But don't forget, this is strictly for grinding tools. And I'm running a pretty much standard cup wheel that I'm going to run. But I'm also building this table so there's plenty of in and out. And that's what these are for. So these are some really good roll-on MSR 15 ball bearing slides that I bought used off on eBay. And when I get done, I'll put a link in there because this gentleman has tons of them. He's very nice to deal with. Instead of $200-300 a set, these were like $38 for two. So for the bearings and to the glides, and they're beautiful. So anyway, this I always start out with a piece of plywood or whatever, because it's a whole lot easier to lay it out, drill all these holes. If you're wrong, you zip out a new one. You do this out of steel or aluminum plate, and of course things get difficult rather quickly. But as you can see, one of the things when you go into angle, you have to have clearance here for your table. Also, you probably can't see it in frame. Yes, you can. Down here where my hand's at, the crank won't go on, so I'm going to have to put a cutout in here because I don't need all this in the middle anyway. The table is right here. So right now I'm getting ready. I've got to figure out what my next table is going to look like. You know, and these are just scrap pieces I've got. So this next table will go this way, in and out, towards, so I can run it in, and I'm going to use a crank, a lead screw, but I have to get room. See, everything is so tight, I have to get room under here. So these are going to have to be shimmed up. So there's a lot of figuring, and well, anyway, that's where we're at. All right, well, I'm pretty happy with the functionality of my plywood setup here. So I think I'm going to go ahead and bite the bullet and make this bottom plate. And this is a piece of 1/4-inch plywood with another piece of 1/4 on top of it to get clearance for my lead screw and this assembly here to go in there. So it'll slide in here like so, which will allow me to crank this back and forth. And I got this piece made, a template to set on top, and as you see, this goes back and forth pretty well. And I've got a mixture of 3.5 and 4 and different. I've got cup wheels and all sorts of stuff, and of course every one of them has a different arbor size. So anyway, I'm going to go ahead and make this bottom plate here out of aluminum and machine it to where these glides set down in just a hair, and etc. So see you over at the mill. Alright, so here once again I did something I hate to do, is pull the vise off, and this is the piece of 1/2-inch aluminum plate I roughed out on my table saw using a carbide blade. And I've got some 1/2-inch parallels sitting in here to keep it up off the table. And I have a pair of adjustable parallels, which I showed you before, that I put in my back T-nut slot, and then I simply tap them in place, and what that does is it tightens them up really tight. Alright, so the next thing on these small mills you have to do is to use that back T-slot. My 1/2 inch bit won't clear here. Alright, so I'm going to stand them off with a couple smaller parallels here, if I can pick them up. Like so. And this will give me the clearance I need to get the milling machine cutter down and in place. Alright, we got this thing clamped down, and now all I have to do is run back across it. And this is just a little spring pass. That probably should be a couple more thousandths. It was off about 15 thousandths by using my table saw rip fence, which is pretty good. And I'm not going to bore you with this going all the way across. So we'll see after we get all these sides squared up.